All right, so last thing that we have to learn for AP chemistry reaction-wise anyway is a complex ion is a metal ion that's surrounded by a whole bunch of either other molecules or other ions surrounding it. So basically what's going to happen is you're going to form what's called ligands, which are basically surrounding ions. It's like Justin Bieber being surrounded by bodyguards. Think of it that way. So the most common number is either going to be 2, 4, or 6, and it's usually dependent on the charge of the metal ion, because remember, it's mostly transitional metals. Double the charge, and that will be the number of ligands that will bond around it. So the most you could possibly put around is 6 if they're attached to the same ones. But basically, the key is try and make the AP sure that the AP graders that the charge makes sense. I'll show you as I write them out that the charge makes sense. Common one is Ag. So, for example, Ag forms a complex ion with ammonia. If you see ammonia, the charge on Ag is +1. If you double it, that means you put 2 ammonia molecules around it, so the subscript is going to be 2. And then all you do is you transfer the charge of Ag, which is +1, to the charge. That's what I mean by making sure that the charge makes sense. So basically, you take the charge of the metal, double it. That's how many that is going to surround it. If it's a molecule, that doesn't contribute a positive or a negative charge, so you just transfer it over. If it's a negative ion like Cl minus or OH minus, that's when you have to be aware and count the charges from one side to the other. So let's take a look. What's happening on a molecular level is you're basically just taking a metal right here, and you're surrounding with a bunch of different ions. Complexation is basically what it is. So you have a central metal ion. Ligands are the ones that form around it, kind of like Justin Bieber getting surrounded. I said that already. So if we look, double the charge on the metal ion, that will tell you how many ligands that will form. So if you look, Pb, notice Pb right here is 2+. I'm going to double that, so I'm basically going to need 4. So in this case, if I'm reacting, the key word they'll say in the problem is excess or concentrated. You'll see that in the problem a lot. So that'll tell you which one's going to basically be added to form the ligands. So basically, I'm going to double the amount of OH. So I'm going to write Pb, OH to the 4th. OH, each OH is negative. So if I have 4 of them, I'm contributing a -4 here. And then Pb normally has a charge of 2+. So the overall charge on it's going to be -2. Aluminum's the only one that's kind of a weirdo. Aluminum, when it reacts with hydroxide, forms 4. You have 4 OHs surround aluminum. So what happens is you have OH concentrated or excess ammonia is added here. Or excuse me, hydroxide is added. So what's going to happen is they're going to react. 4 of those, you're going to get Al parentheses, OH4. That's going to cause a charge of -4 from the OH. Aluminum's +3. The overall charge of the ion is -1. Zinc. Charge is 2+. I double that to 4. So I'm going to add 4 OHs. I'm going to end up with Zn parentheses OH4. That's going to have a charge of -4. Zinc is +2. So overall, it would be, the formula would be Zn parentheses OH4 2. Common one that's used in AP. If you take Fe3+ and SCN, you make up FeSCN 2+. That's 1, just straight memorization. It's a 1-to-1. And then figure out what the charge will be. So, solid aluminum hydroxide. Key word is focus on the solid part. Solid aluminum hydroxide is going to be AlOH3. Is added to keyword concentrated solution. Potassium's a heartbreaker of potassium hydroxide. So I add the OH there. The fact that it's concentrated or excess means that you're going to have a complex ion form. And remember when I talked to you about aluminum, aluminum is going to be Al. It's going to form with 4 OHs, and then the overall charge is going to be -1, -1, because aluminum by itself is going to be +3 with 4 OHs, each negative. It'll have an overall charge of -1. A lot of times these can be shown with little bracket things like this instead, and you can write the charge on the outside. You could write it almost either way. So there's an example. Aluminum hydroxide is shown as a solid or shown all together because of the keyword solid. You always just write the formula. If it's a solution, cancel something that you know is always going to be soluble. You get the product using the little trick on the other side, make sure the charge balances, and you get your points. Saturated sodium fluoride solution. We know sodium is a heartbreaker, so all I'm going to do is put fluoride. The fluoride ion is going to be F minus. I'm reacting with aluminum sulfate. So aluminum is going to be surrounded by the saturated or excess is going to be the one that's going to. Aluminum has a charge of 3 plus. I double the charge. 3 doubled is going to be 6. So when it forms a complexation, it's going to be AlF6, right? If I put the little bracket things around it like this, the overall charge is going to be 3 negative. Each fluorine is -1, so I'm going to get -6 total. Aluminum's 3 plus. The overall charge of that molecule is going to be 3 negative. Then to balance it out, I would have to actually put a 6 over here to make sure it was completely balanced. So then I'm good to go. Next one. If you look right here, excess aqueous ammonia. So ammonia is NH3. The fact that it's excess and concentrated means it's going to surround somebody. We have solid silver chloride. So I show it as AgCl as a solid. Who's it going to surround? It's going to surround Ag. The charge on Ag is +1. So what I'm going to do is I'm going to take Ag, then I'm going to take parentheses NH3. I'm going to need 2 of those. The overall charge on the molecule is still going to be +1. Why? Because NH3 does not have a charge. So when I put it into a complex ion, the overall charge is going to be, when it's a molecule like NH3, the overall charge is going to be the same as the charge of the metal. And I am good to go. I also have to add Cl minus on this side because it's a solid on this side. When I cut it loose, I have to show the ion. It's basically NH3 is kicking Cl out. All right. Next one. Excess concentrated potassium hydroxide. That means hydroxide is going to do the surrounding plus solution of nickel 2 chloride. Cancel the chloride because it's a solution. So I'm going to show nickel 2 plus. What's nickel 2 plus doubled? It's going to be, well, 2 doubled is going to be 4. So I'm going to write Ni parentheses OH parentheses 4. The overall charge is going to be 2 negative. Why? You can put the little brackets on this thing if you want. It's almost the same thing. That's how they show complex ions. That's how they write it. Why is it going to be overall 2 negative? Nickel is 2 plus. If I add 4 hydroxides, 1 negative each, the overall net charge is going to be 2 minus. The last thing you need to do is balance it by busting out a little 4 there, and you have your complex ion reaction. Not too bad. Key words are excess or concentrated. That's going to tell you what's going to do the surrounding. You take the metal ion, surround it using the double rule, and just make sure the charge works. All right? Have a good evening. I'll see you tomorrow. It is almost over.